first part of this lecture, we talked about Diophantine equation, an equation like a square plus b square equal to 3c square. And we are interested in the integer solutions. We are interested in integers a, b, and c which satisfy this equation. And we showed that there is a geometric way of thinking about this equation. They are the rational points on a circle of radius square root of 3. If you have not seen that part, you can go back to the first part of the video, which is on the discussion page. In this section, we will talk about a purely number theoretic treatment of this problem. So, as usual with many number theory problems, we will do something called modulo checks. If you are aware of modular arithmetic, then you will be able to follow this logic. Any number a is either 0, 1, 2, or 3 modulo 4. In other words, it gives remainders 0, 1, 2, or 3 modulo 4. So if we square it, if we square a number, then we get 0 square or 1 square or 2 square or 3 square modulo 4. So it is not immediately clear that if we square the number, we can square the remainder as well. It requires a little bit of work, which usually is done in an introductory number theory class. But if you compute it, if you know that, and if you compute these, you'll get 0 square is 0, 1 square is 1, 2 square is 4, which is obviously 0 mod 4, right? Because if you divide 4 by 4, you'll get the remainder as 0. And 3 square is 9, which is 1 mod 4. So the interesting thing is that if you take any square number, the remainder is always 0 or 1 modulo 4. This will help us a lot in investigating what's this particular equation. So let's look into the equation one more time. A square plus b square equal to 3c square. Now, since the numbers match up on both sides, that is, since the left hand side is equal to the right hand side, hence the remainder on the left hand side when divided by 4 will be equal to the remainder on the right hand side when divided by 4. And that is the key idea in solving this problem. So notice that c square is congruent to 0 or 1 mod 4. And that's because any square number is either 0 or 1 mod 4. So 3c square is congruent to 3 times 0 or 3 times 1 modulo 4. So 3c square is congruent to 0 or 3 modulo 4. So we know that the right hand side gives remainder 0 or 3 modulo 4. Now at this point we will stop here because I want to give you an opportunity to work the rest of the problem on your own. If you can do it, then it's great. And if you cannot, then proceed to the third part of the lecture and we will solve it completely there. There is a link in the description to the discussion page. Thank you.